Okay, question number 6. How much current will this motor draw if its shaft is seized while trying to rotate? Now then, remember this motor has 2 operating voltages, 230 volts, 460 volts. So you can give me one of 2 answers. You can give me the current at the low voltage, or you can give me the current at the high voltage. I don't see any need for you to calculate both, but I do ask that you state the applied voltage, meaning the voltage that you have chosen, to come up with your answer. Okay. Back to question number 6, okay? Voltamperes. Voltamperes is always abbreviated VA, okay? It sometimes has another name, and in this application, we don't call it by that name, but the other name is apparent power. Okay, it's apparent power, and it has that name to distinguish it from real power. And there's a long discussion of history that goes with that. We'll stay out of that. But it normally means in single-phase circuits, AC or DC, it means volts multiplied times the amps flowing in the circuit. Okay, now remember that in 3-phase power, that I'll just say VA, and I don't want this to be confusing, for 3-phase is equal to the square root of 3 times the current times the voltage flowing in the circuit. And you've seen this in the 3-phase power equation. What it doesn't have is it doesn't have the power factor included with it. Okay, so our charts that we've been talking about for locked rotor, okay, you see we've been talking about VA and KVA, and it does not matter for locked rotor. This chart doesn't care whether you're talking about a 3-phase system or a single-phase system. But you and I know that we are working with 3-phase systems right now, 3-phase motor. So let's take a look at our nameplate again. If we can, I have elevated my camera so it may not be as clear, but we've got a choice of 2 voltages, 230 volts, 460 volts, and for 230 volts at full load, we will draw 7.8 amperes. For 460 volts at full load, we will draw 3.9 amperes, okay? So the 7.8 belongs to the 230 and the 3.9 belongs to the 460. So let's pursue this a little bit, okay? So we have a locked rotor code of K, and that means I'm going to pick a mid-range. If you remember, it was a range of 8 to 9 kVA per horsepower, right? So we'll pick. Let's pick. locked rotor kVA is equal to 8.5. Pick it right in the middle, okay? If you're talking hypothetically or sitting in an office and working out some problems and doing some what ifs, that 8.5 will do well. On the plant floor and operations, you may have to be careful with whether you use the upper end or the left end of that range. Okay, you may be setting some circuit protection with it, and then you'll be more prudent about it. But this is good for us. Locked rotor kVA of 8.5. Again, that's kVA per horsepower. Now then, our motor is 3 horsepower. So the locked rotor kVA will be equal to, what's that, 20. 25.5 kVA, and that comes from multiplying this number by 3 horsepower, gives me 25.5 kVA. So you'll notice that the horsepower is gone from the denominator as a result of multiplying. So what we want to do, we're trying to determine how much current the motor will pull. So let's work for 230 volts. And let's say I'm going to run out of room here, so I'll let you get this information down. Okay. So let's say for 230 volts, connected to the motor. Then the volt amperes will be equal to 25,500 volt amperes, and that is going to be equal to the apparent power, okay, for 3-phase. So that will be the square root of 3 times the current, which we're trying to find, but we have said that the voltage is 230 volts. Okay, so I have an equation I can use here. The unknown is I for current. So if I do my transposing, I'll get that I, my current, will be equal to 25,500 volt amperes divided by the square root of 3 multiplied by 230 volts, okay? And my volts will cancel out. That'll leave me with amperes. So this will give me 32 amps. So if my motor, the one we've been talking about, If my motor encounters a locked rotor condition, okay, and it is connected for 230 volts, it has this locked rotor code K, and we talked about the range of it, right? And we decided we would use 8.5 kVA per horsepower. So for 230 volts connected, the voltamperes from our chart is 25,500 voltamperes, and that is equal to the apparent power equation of three-phase. The unknown in that is the current, and that's what we're looking for. We want to know how much current is being pulled by the motor when its rotor has been seized. And we transpose the equation and come out with the statement that I is equal to 25,500 divided by the square root of 3 and multiplied by 230, and that gives me 32 amps. Now then, I'm not going to do that, to see what the current would be at 460 volts. Okay. Let me check my math. Okay. Ooh, no, made a mistake. I did. Anybody catch me on that? Congratulations if you did. I hope you have the courage to say something to me about that. That answer is 64 amps. And if we had been connected for 460 volts, then it would have been 32 amps. My apologies for my mistake. So that will be 32 amps for 460 volts.